students, coming to the next topic in the subject database management system is relational algebra. Now let us see what is this. So the main use of this relational algebra is it is used in the design of transactions. So whatever the transactions we are doing, it is this relational algebra is used in the design of transactions and forms the conceptual basis for structured query language. So the main use of the relational algebra is it is used in the design of transactions and forms the conceptual basis for structured query language. And it consists of relational algebra consists of operators and manipulators. So whatever the language we are using, that relational algebra, that language consisting of operators and manipulators which apply to relations. Those operators and manipulators are applied to relations and give relations as a result. But one thing, so whatever the result that you get, that do not change the actual relation in database. But do not change the actual relation in database. So that is the main concept of the relational algebra. So whatever the relations we are using, and by using these operators and manipulators, it consists of operators and manipulators which apply to relations, means which apply to the tables, and after doing the operation we will get some result. So that result do not change the actual relation in database. So that is a relational algebra. So this is called as this relational algebra. It is a procedural intermediate language used within the database management system. So whatever the database management system we have taken, this relational algebra, you call it as a procedural intermediate language, so which is present in the database management system, acts as an intermediate language. So we just take the relations and perform the operation, and again we will give the relation only, just like a tables. So whatever the table we have taken, then that will give in the form of a table, that do not change the actual relation in database. So let us see what is this relational algebra. That will do in the database. So I said that this is an intermediate language. So first a parser is there, and then some expressions, and here you are having the code generator. Okay, so here the input we are giving is SQL query. So database management system, so you think this is completely a DBMS. This is DBMS, database management system software. So in the software, I said this relational algebra is an intermediate language. So we are just taking the SQL queries, so that in the database management system we are just with the help of the tools we execute the SQL queries. So SQL query is giving input, okay, and this parser converts into relational algebra expression. So whatever the SQL query is there, that will be converted into relational algebraic expression, and then it will be becomes optimized relational algebra expression. Okay, So SQL query is converted into relational algebra expression, and then it will be converted into optimized relational algebraic expression. Whatever the relation that is optimized, so that will be sent to code generator with the help of query execution plan. So with the help of the query execution plan, it sends to the code generator, and finally you will get the executable code. So this is done in the database management system software. So we are taking this SQL, they are taking the SQL query as an input, and after that it converts into relational algebraic expression. Whatever the relational algebraic expression that is there, that will be optimized, and with the help of the query evaluation, query execution plan, this will be sent to the we'll get the executable code with the help of the code generator. So this complete here, this taking the relational algebra and optimizing the algebraic expression, you call it as a query optimizer. This two you call it as this is a query optimizer section. So what is a parser here actually? What is a parser? A parser is nothing but it is a compiler or interpreter. Whatever you are taking, it's a compiler or interpreter. You just call it as a compiler or interpreter component that breaks data into smaller pieces, okay, smaller elements for easy translation into another language. So we are just translating the SQL query into another language, that is a relational algebraic expression, intermediate language. So this parser component is useful to generate, means is useful to break the data into smaller pieces, smaller elements for easy translation into another language. Okay, so this is about the relational algebra. Now let us see what are the advantages in this using this relational algebra. This is just the introduction I am explaining. So the first advantage is the mathematical background of relational algebra is the basis of many interesting developments and theorems. So this is one of the mathematical background. A mathematical background. So with the help of this mathematical background of relational algebra is the basis, this mathematical background of relation is the basis of many interesting development and theorems. So to develop theorems or some, if you want to develop some mathematical issues, so this relational algebra is very useful. And one more thing, if we have two expressions for the same operation and if expressions are proved to be equivalent, then with the help of this query optimizer, you can automatically substitute the more efficient form. So the main use of the query optimizer is substitute the most efficient query. So whenever you get the equal same expressions with the same operations and same expressions, everything is same, and we are that has proved to be equivalent, they are proved to be equivalent also, but we have to take only one query, so based in those two tables. So then this query optimizer can automatically substitute the more efficient form. Okay, so that is one more advantage, that is a query optimizer. With the help of this we can evaluate the more efficient form. Okay, so this is the advantages of relational algebra. Thank you.